Hi, everyone. Awesome to be here on a sunny, blazingly hot day here in Austin, Texas. Yeah, I'm going to jump through quite a bit of information very quickly. My goal is to introduce a lot of topics naturally in 40 minutes or so of presentation. We're not going to be able to exhaust really anything. The goal is to really dig in a bit on the shift that's taking place and how we can move to address that shift. And let me get the slides up and running. All right. How's that? Can everybody see the
Good to go.
screen there? Awesome. All right, so we're going to talk a lot about the shift that's taking place and how organizationally we go after improving or shaping ourselves in such a way to take advantage of the shifts that are taking place in the public cloud world and private cloud world for that matter. And so what we're seeing in the market space is, oh, and hi, Michael, is the more obvious transition is that there's this move to become a much more dynamic infrastructure kind of world. And so as we saw things like the public cloud emerge on the scene, it became something of an asset where we could do some sandboxing, testing, and really go after those more dynamic forms of engagement. So those systems that were more user-facing that we needed to iterate on quickly in order to stay competitive in like a digital marketplace. So in the private cloud or private infrastructure world, we were often focused on things that were more systems of record, things that were a little less dynamically moving. You know, the way that you produce things like your financials at the end of the quarter don't require hyper fast, iterative design work to take place. But when we start talking about things like the mobile device that your mobile banking customers are using, then yes, we're looking at something that's quite a bit more dynamic. And the public cloud providers introduced a more dynamic consumption model for the way that we get resources assigned to us. And so the shift that's really going on, and it's not really a public-private, battleground, if you will. It's more of a shift away from sort of static management and operations of IT resources into something that's quite a bit more dynamic. And part of the reason for that is kind of a lot of what I've already been talking about is that the firms that are actually moving very, very quickly and can run cheap experiments against their user base and learn what it is that makes them more valuable to their end users and consumers are the ones that are winning in the market space. And so typically the folks that are leading or outperforming are moving very quickly, deploying many more times than their competitors are, and they're learning actively in production from their end users. And so what does this shift look like? What are the implications of this shift, right? From the perspective of provisioning, we're moving from dedicated servers with physical and/or virtual machines. And these typically were things that were very long-lived. So I would stand up a virtual machine, but it often had the same lifespan of a physical server, or maybe much longer than the physical servers. We might rev the physical servers and keep a VM for longer than the lifespan of the hardware. As we move into a much more dynamic world, we're looking at servers that are provisioned and then destroyed, and much more dynamically. They need to be provided nearly instantly, and they need to go away nearly as instantly. But it's still a mixed world. We still are talking about VMs, we're talking about containers, and we're also talking about things that are like serverless or event-driven infrastructure spin-ups and spin-downs. As we talk about security, we're talking about a world of high trust. So typically in the data center, we have a very hardened outer perimeter, and we felt like anything outside of that perimeter was bad, everything inside the perimeter was good. And so I had this high trust expectation for my networking inside in-house, if you will. And so because assets weren't moving very quickly, we could track those assets and secure those assets by IP and with a clear, well-defined network perimeter. As we move into this multi-cloud world, the threat model is more of attacker on network, not outside the network. I don't really have a clear network perimeter. Things are kind of materializing and disappearing. more dynamically. And because of that, IP becomes something that's very difficult for me to track that asset or secure that asset. So I have to move to more of an identity-based model that we'll talk about going forward. And this allows us to talk about things like low trust or zero trust networking or low trust service interactions, which leads us into the networking conversation. So as we're talking about, I've provisioned some infrastructure, I've secured or dealt with kind of access patterns and credentialing, et cetera. Now I'm dealing with sort of connectivity. Can I find something that just moved from one cloud to another cloud? That's step one. And then once I find it, do I have the correct access privileges to talk to it? Are we securing things in motion? Those types of questions become important to us as we start looking at the networking aspect. And again, we're moving away from IP as the control plane to identity or a dynamically assigned service name. And then finally, we're changing the way that we deploy applications. We're moving away from purpose-built applications for a particular platform to applications that are designed to work on a fleet of existing infrastructure. So rather than build an app for a particular VM or operating system, et cetera, it's going to be more containerized workloads. It doesn't have to be containerized, but a lot of folks, when they think about scheduling assets across a fleet, are typically thinking in terms of containerized workloads, and then we're provisioning it or scheduling it to run on the fleet. And so these changes yield a plethora of choice. So as we talk about the various models by which we deliver these services, they tend to be somewhat siloed based on the cloud that you're choosing for your implementation. You know, if you're OpenStack on-prem, then you may be looking at things like Red Hat for some of those provisioning technologies, your Kubernetes installation, et cetera. But the point is we have very platform-specific implementations to make all of these workflows happen as you go across cloud, which leads to kind of some skills sprawl. And so where HashiCorp steps in to try to simplify and make life easier for customers to be able to adopt this cloud operating model is we bring what we're calling systems of coordination or collaboration that will allow us to provision consistently across any sort of paradigm for IT, whether we're talking on-prem with physical infrastructure or VMs, or public cloud, or even private dynamic cloud using containers or service, serverless or edge devices. And so our goal is to make sure that we look at things from a workflow perspective. So if we're talking about provisioning infrastructure, that is a workflow that we can get consistent on across multiple clouds. If we're talking about security, the same thing. When we're talking about networking, same thing, and scheduling applications. So our goal is to simplify the delivery of these services on demand across any infrastructure in a multi-cloud world. So let's talk about how this moves us more into that DevOps world. So typically, we're moving from static to dynamic, and we're getting focused on self-service for the developer. So if the developer is going to build something and run it, and they're going to be responsible for the operational heavy lifting associated with that. So if you're talking about DevOps in the Netflix sense, it's the you build it, you run it kind of mantra, then developers have an expectation of a self-serve sort of environment. And so if we're moving away from an ITIL, ITSM driven ticketing experience, where it takes me a couple of weeks to get a VM, maybe it takes me a few weeks to update the load balancer and a few more weeks to get firewall rules updated, et cetera. I need to move away from that to something that's much more dynamic and allows the developers to experiment and move quickly. And so we end up with kind of bloated terms like digital transformation, which is really just saying that our business, the front end of our business is now transforming. So I'm no longer strictly a point of sale system for physical stores. If I'm the Home Depot as an example, I am transforming the business to become an online player as well. And so that constitutes sort of a digital transformation. It's no longer about just back office systems. And then another aspect of that is I'm becoming much more automated and dynamic in my ability to deliver new applications. So another aspect of digital transformation as we define it is the process shift to become much more dynamic in the way we deliver. And then it also is associated with things like cloud adoption. And so I'm not looking to manage whole fleets of infrastructure. That's not a limiting factor for me. I'm able to burst out, use the cloud for what it's good for, which is things like scale, bursty workloads. In some cases, I can drive out some cost and have some better efficiencies. And we'll talk about some of those use cases a little bit later on, but this is how we would typically define digital transformation. And so this leads to a lot of challenges. The obvious challenge that we were talking about, or the obvious shift, is the shift to more of a self-service infrastructure demand. But as we start looking at organizations, the culture challenge, the people challenge becomes probably the less intuitive and a little bit more difficult challenge for us to overcome. As we look at traditional organizations, we see that we are organized by specialized skills. If we're looking at a Cisco team, they are Cisco certified engineers and they focus on managing our Cisco backplane. And so we set them up with KPIs to measure how successful they're being. And so we provide processes and systems around that provide to measure and to buffer that team from too much demand or stress, right? So if I constantly have a flow of people asking for changes, I'll put like a ticketing system between them and the end user in order to kind of buffer that blow. So it's just not chaos, right? I need to organize the work, so I build out a system to underpin the process of that ITIL ITSM flow, and then provide measurement so that they can tell whether they're doing a good job or not. As we look at the transition, there's this mythical beast out there that we call the DevSecOps unicorn. The engineer who knows the IT systems backwards and forwards and can basically do it all from a single seat. And the challenge there is that generally speaking, I don't believe that these folks exist. We've actually run some experiments with some very large enterprises where we tried to put teams of what we would call operations generalists together, and we end up with some anti-patterns that don't fully express themselves in the most positive way. We'll put it that way, because you end up with skills gaps. You end up with, I really understand networking very, very well. I'm kind of light on security, but I get that we need to do X509 for mutual TLS. So I'm going to look at, I'm going to look up some patterns online and I'm going to apply those. And so we end up with kind of some shortcuts that lead to some fragile approaches as we have a quest for these DevSecOps unicorns. So rather than establish a process which is focused on, having an operator that knows everything, we'd rather focus on understanding that there is going to be a specialization of labor in our IT shops. And so what we want to do is we want to help these individual constituencies develop into the best version of what they can go out and deliver. So for the developers, one of the key changes that we've seen there is obviously much more autonomy because of the self-service nature of cloud, but also a heavier load in terms of responsibility, because now they're responsible for how it operates in production. And they are typically on the hook if something goes south. If you're a Netflix engineer and the streaming service goes down at 3 a.m, you are the one who gets paged to fix the streaming service. There's not an ops team obfuscating you from that ticket because you now have service ownership. So we empower the developers, yes, but we also add additional responsibilities to their daily lives. And so operations then shifts a bit. They're not necessarily responsible for, maintaining 5 nines on this set of Windows servers, which good luck if that was the job. They become more site reliability engineering focused, which means that they're focused on, the way that we do it here at HashiCorp is we actually embed an SRE in the dev team. And part of the reasoning for having that SRE embedded with the dev team is to maintain consistency across dev teams. So we understand the operational principles that we use to measure Audit, all of those kinds of things. And their focus is on making sure that those developers get all of those best practices sort of instilled when they're building out their applications to consume infrastructure. The same thing could be said of networking, that it's no longer about being the world's best at managing things like routing tables. It's more looking at service networking as a holistic service that's going to be delivered. So how do I provide connectivity as a service to my end users and developers? And the same thing's true of security. Rather than being an audit that happens after everything is complete and then we kick it back to the developers to figure out all the ways that they broke our manual audit, it needs to become very automated and service-based. So I want to make sure that you can get security applied as a policy up front, and you can dynamically consume it. So you assert your identity, or the service asserts its identity, and then we will automate the delivery of credentials for you, so you're not waiting in a ticket line for like a username and password for a database, those types of things. So we'll talk about how we deliver that as we go forward. But essentially, we build processes for individuals, and we start organizing teams, which are combinations of these skill sets, in order to deliver value for the enterprise. And then we can structure processes around how those different teams communicate with each other. So software ultimately comes down to the challenge of communication between different constituencies. So if we go back and look at the ITIL process, we kind of described this already. The ticket queues, where I'm requesting different teams do different things for me. This is how a lot of traditional organizations are set up, to capitalize on the expertise of an individual team, but also to buffer them in such a way that we can kind of measure their goals and objectives and outcomes and PKIs. But for the development team, this looks like a big delay, especially if we're talking about manual processes that are taking place in the background that is preventing me from getting to production with a new idea. And so one large telco that very graciously worked with us to audit their entire conveyor belt of software delivery found that they had over 72 tickets that had to be filed by a dev team before they could release a new piece of software into production, which on average was something like 10+ months to get time to value in the dev process. So this is something that it's not uncommon at large scale enterprise to see these types of things. And part of the reason here is I want to be careful, because it's very easy to look at what we did and say, oh, that seems backwards. But it was a natural, very organic thing. We were trying to take advantage of specialization. We were trying to get the best of breed from every technology that I got introduced through the 80s and 90s and 2000s. And so as we brought on a new piece of technology, we would simply set up a team to become world-breaking experts in that technology, and then establish a ticket flow to provide that to the larger organization. And so it quite naturally ends up in looking something like this. So the existing, what I've talked about before, I want to capitalize on that expertise. So ownership of a technical domain, expertise in that particular technology. And then we have to set up some form of gatekeeping, so it's just not a Wild West and that team doesn't just get burnt out in the first 10 minutes of operations. And so some of the necessary changes are, rather than be focused on an endpoint technology, we are responsible for a process domain. So like networking as a service, that's not, we're not breaking that networking team into 4 or 5 different teams that are responsible for load balancing, firewalling, et cetera, et cetera, et cetera, DNS assignment, whatever. We want to have that process domain as networking to be a team that is building out self-service capabilities for that process domain, and then essentially drive it out as a self-service domain. And so as we're talking about DevOps as an example, the development team is now interacting with the various process domains via API in a self-service manner. And those APIs, where HashiCorp really comes in, is we're looking to provide those new systems to underpin that self-service process. And so we'll call that a system of coordination. And so as we think about the changes, we step back out again to the larger organizational shifts that we see going on. The people are going to learn new skills. They're going to become very automation focused. So it's not about, really I mean, you want to understand vCenter inside and out still, but it's not going to be receive a ticket, go to the vCenter UI, do something and close the ticket. It's going to be about, okay, how do I automate that so I never have to do that task again? And so I need to really goal the team against automated outcomes as much as possible. So the process is going to be focused more on self-service enablement and the workflow orientation. How do we move code from A to B to C to D, et cetera? And my piece of the workflow may be provisioning of infrastructure. And so I'm going to be oriented on how do I provision infrastructure the cleanest, safest way possible in a self-service way that the consumers, my development team, can consume it very easily and intuitively as part of their pipelines, maybe behind ServiceNow integration, some way that makes it very simple for them to consume. And so the systems that underpin that process need to adhere to that kind of cultural outcome that we want. Can I drive it via an API? Does it allow for cross-team coordination? Those types of things. If I want a collaborative environment, I need to make tool selections that facilitate that cultural outcome. So as we're talking about systems of coordination, one way that an ops team will interact with a development team, as an example, is via the ticket queue. And that's the API, right? That's the contract that I've made it available for that development team to consume. What I'd like to, rather than have it be a ticketing process, I'd rather it be more API, and we've kind of talked about this quite a bit. And the idea behind that API system of coordination is that now I can sort of collaborate. So I don't want to just provide provisioning as a service. I want to provide safe, clean, compliant provisioning as a service. And so I would like to collaborate with the security and compliance and governance teams to apply, let's say, policy as part of the infrastructure rollout. And the best way that I can do that is I have the development team providing an input saying, we need this type of a service. I need Datadog at scale in cloud X. Do we have that in our library? Can we provision it? Do we have policies for that? And the ops team would build the automation to deliver Datadog at scale in whatever the cloud is. And the security team would come in and write policy that would be automatically applied when that infrastructure gets provisioned, as an example. And so this is why we're calling it more of a system of coordination, as opposed to maybe like a scheduler, like the ticketing system was. So let's separate a couple of buzzwords. One is infrastructure as code. You'll hear HashiCorp talk quite often about everything as code, networking, provisioning, security, et cetera. But when we're talking about infrastructure as code, there is a lot of benefits that kind of come with that construct. The idea of code, obviously, is that I don't have to manually do things. It obviously, it kind of goes right at automation as the goal. And so the idea here is that when the operations team builds the infrastructure as code, it's imminently reusable. I can call it over and over and over again, and I don't have to have a ticket that goes back for somebody to do that task again. There are several benefits here. One is just clean audit planes. So the fact that I have the infrastructure defined as code lets me go look at what was provisioned, when was it provisioned, what was the intent behind it, was there an error, is there a difference between my infrastructure code and what's running in production? Like, I can ask a lot of really interesting questions because I have a codified delivery of an outcome. The other thing is I can start treating my infrastructure code like source code. I can compare differences as I'm developing something new. When we talk specifically about Terraform takes the approach of having a core, which is the ability to, well, you'll hear us talk about, you write your infrastructure as code, Terraform will run a plan phase, and that plan phase looks and interrogates your infrastructure and comes back with a series of steps that it's going to expose, or that it's going to execute in order to make what you asked for into reality. Now that plan phase actually is another clean audit space for us because I can see what are the changes that are going to happen in production. Now, before I allow those changes, which we call the apply phase, Terraform would then go to an apply, which would make the plan real. Before I allow the apply, I want to run a policy check against that plan output and make sure I'm not introducing a security hole or some fragility. Maybe I want to make sure that I am not exposing an S3 bucket to the public internet. Those types of things that in a cloud are super easy to just say, make that public. And AWS will say, absolutely, your wish is my command. I want to have some policy to help govern the role of these of infrastructure out into production. So this is where we get into that system of coordination around provisioning. And the cool thing is because these providers, we come out of the box with just a ton of providers. And these providers are anything from the public cloud vendors to things like I mentioned Datadog earlier, or Palo Alto Networks, or whatever. That allows me to kind of abstract away the complexity associated with kind of provisioning these things. And so I write some simple declarative HashiCorp configuration code, and then push that over to Terraform, and Terraform spins it up in whatever cloud that I want. The key here is that it's consistent across all of your clouds, including things like vSphere. So split execution from definition. I write the definition as code, and then execution is something else, and that's a separate audit plane. So I get a state file telling me what's in production, and I get a plan file which tells me what changes are being proposed with this latest infrastructure as code. And then because it's becoming API driven, it's very scalable and consistent and well documented. I can go back and see what we were doing when. Now, as we get through the provisioning phase, we start looking at, in fact, this is how Vault was actually created, was we were working with some large banks and financial institutions, and we started running into scenarios where we were looking at the secrets in the clear for configuration. And we felt that there had to be a way for us to kind of obfuscate that or hide it from ourselves as consultants. And so we kind of created a system of indirection that we eventually became known as Vault, which would allow us to essentially aggregate identity in a centralized system. And when I ask for credentials to the database, as an example, I tell Vault that I would like to have access to the database, and it validates, is there a policy in security which says you have rights to access the database? And what level of rights do you have? So I check that policy, and if I get a thumbs up from Vault that you are who you say you are, I vetted your identity. That can come in a number of forms, credentials, MFA, a bunch of different ways that I can vet your identity. But I vet the identity of the caller, and then I can go to the system and generate a user ID and password, which I encrypt, and I hand you a token. So there are no passwords in the clear. There's no usernames and passwords in the clear. It's all ciphertext. So again, very simplified workflow to allow security to provide self-service access to back-end systems and resources. Now, once I have that simple workflow in the middle, I can begin to extend out into a number of other areas. So secrets management becomes a much more involved conversation because I can manage the complete life cycle. The example that I just used is what we would call dynamic secrets. And that is, you've never had a username or password to the database. I created it on the fly based on the policy, and your identity is correct. And then I sent it over to you. Now, when I say dynamic, it also means that I'm establishing things like shorter time to lives. So rather than having, a username and password for an Oracle database, so you got Scott Tiger written into your application code to talk to an Oracle database. And typically those credentials were set with a time to live of like 10 years because the database admin who issued it wants to be out of that job before that credential expires, and we end up with a Sev1 outage. So with dynamic credentials, we want to eliminate that possibility of a Sev1 outage because of an expired credential by managing that time to live, and making sure that we refresh and get you a new credential as the old one expires if we need to keep you long-lived connections. At any rate, there's a lot that we can talk about dynamic secrets, all sorts of things that we can do with those. We get very interesting use cases right now, especially with many of the larger banks around things like data encryption. So because I have this centralized identity broker, which determines if I have access or rights to particular data, I now can do things like call Vault and say, hey, here's a social security number. Can you encrypt that social security number for me and just send me ciphertext? And this gets really interesting because it's not only kind of encryption, but now I'm getting into things like format preserving encryption, where I'm still going to get 9 digits in return. And that's what I store, but it's not the actual user's social security number. So even if I have a breach, the format's going to look appropriate in the database stores that I'm using, especially in, again, if we're talking about enterprises that have been around for quite some time, that may be going back to a database with a well-defined column. We want to make sure that we meet that, or maybe for visibility reporting, et cetera, it needs to meet that format. So we want to make sure that we encrypt and keep it in the correct format for storing it and retrieving it. I'll kind of stop there because we've got a lot to go through, but Vault basically, again, starting at a simple workflow, allows us to get more and more elegant with what we can do in terms of security and secrets management. Now, security, we can't really have a comprehensive discussion about security without touching on networking and access. And so we begin to step into how identity extends itself into the network. And so I have a web server that needs to talk to a database. And typically the way that we would facilitate that communication is through a firewall. So I'm going to protect the database. I put a firewall between the database and other services. And I establish a rule which says IP1 can talk to IP2, and the database is on IP2. But as I start to scale out, these rules get pretty lengthy. IP1 to IP2, IP3 to 2, 4 to 2. And if I move into more cloud native paradigms where I'm looking at microservices, and so my e-commerce website is not one monolithic application that's running in 3 different places, it's 100 microservices with 5 instances each replicated in 3 different clouds, right? So these firewall rules become really difficult for us to manage at scale. And so what seems to make more sense to our way of thinking is let's use a registry as a way to understand the more dynamic nature of these cloud workloads and the scale that we're getting to with microservices and many, many different instances. Those instances may or may not be moving, but there's a lot of them. And so if we're constantly updating firewalls in sort of a manual ticketed way, we're never going to be able to match that scale. And so what I'd rather do is register those services and then establish an access rule that just says the web server can talk to the database. And then the firewall then can subscribe, if you will, to that registry and understand when IPs have changed. One of those things that's key in that registry aspect is the ability to health check. And so I can keep load balancers in check. I can keep firewalls in check via this registration process. So I need to be able to scale and enable dynamic infrastructure. And one of the cool things about this registry aspect is that as we get more elegant, we move directly into kind of a zero trust networking posture. Because now what I can do is I can have that web server calls to the database, and I look to see if there's an intent rule, web speaks to database, in the registry, and I can make a determination real time if this is an authorized identity to have that conversation. And generally, after we have that registry, we kind of start with that network middleware automation kind of construct. So the load balancers, the firewalls can register against console, see how things are moving or changing in my environment using those traditional methods of indirection for traffic. And I can just keep them updated dynamically. So I don't have to have a ticket time for an update to a load balancer, et cetera. And then as we move into zero trust, this allows us to have a great deal more security, great deal better security posture across multiple clouds and their disparate networks. And so this is where console comes in. The service registry and health monitoring, I know what's out there. I keep an updated list of who's healthy and who's not healthy. And I can actually begin to manage east-west traffic via console alone using something we call Console Connect, which gets us into kind of that service mesh world. And this is where we've had customers, as an example, retire. I think one customer retired 1,200 east-west load balancers that they were using for indirection to provide security and depth of their on-prem data center. And when we got to the point where console could manage those access patterns dynamically in a software only sort of experience, they were able to kind of retire quite a bit of hardware there. Finally, we'll talk quickly about development, and then we will bring it to a close for question and answer. But there's a big move in the development world to start deploying applications in more portable units that can run on any infrastructure. And as we mentioned, the core principle that shifted is I'm not really interested in running on single machines typically. I'm looking to schedule work across a fleet. Some examples of this might be you want to run a risk analysis like Citadel as an example in the cloud, and you will want to schedule hundreds of thousands or millions of cores to spin up and run this massive query. You're asking a difficult question and you need lots and lots of processing power. A public cloud makes a ton of sense for that. So I can schedule that work, spin up a few million cores, run my analysis, and then flush those cores out again and stop the billing. So, but in order to be able to push those around, I need them in some form of portable unit that's easy for the infrastructure to consume. And so again, typically we're looking at developers who are looking to deploy something. They're going through a ticket team for the operations group, which manages the deployment via runbooks or some other form of manual approach. And the idea here is that what we're providing with HashiCorp is this a solution called Nomad. Nomad is basically a job scheduler. It's not only containers that can be scheduled. We can schedule really sort of any kind of application workload. But naturally, as we're looking at things like Kubernetes is really doing some fantastic work in the market. And there's a lot of discussion about Kubernetes scheduling and getting containerized workloads scheduled across a fleet of clusters in Kubernetes land. Well, with Nomad, we really see scheduling as a simpler heuristic. It doesn't have to be container only style workloads. It can be heterogeneous workloads. And so our goal here is to empower developers to define their application deployment. And this is one of those things that's really awesome about Nomad, is we start applying a lot of that operational discipline that we do at the ops layer. So if we think of operations as below the line and development above the line, a lot of times we have real fine-grained change management policies and everything below the line because we're aware that in operations we can break things and it has a ripple effect. And typically the way that we've handled things like platform as a service is we've said, well, here's your API, good luck. We hope you don't break anything. Part of Nomad's goal here is to codify that deployment and manage it very similar to the way that we would do it on the operations side, meaning I can apply a lot of due diligence, some policy to that rollout. I can make sure that it's meeting our expectations. I can compare the source code for the deployment as it matures over time and what did we change between the last rollout and this rollout. And it makes things very, very simple. So like I can tell it that I want to do a blue-green deploy and things like that. So the goal here is that it's consistent with operations top to bottom. And it gives us a nice clean audit plane for the way that we roll our applications out into production, dev, test, whatever environment we're rolling to. So a lot of folks, when they start with Nomad, they're doing it because they're looking at an easy way to orchestrate containers. But oftentimes, after we get into that, we realize that scheduling is just scheduling. It's not about the container necessarily. We can get into legacy application orchestration just as well as the containers. And then we're seeing a ton of really interesting usage around Nomad, especially for those machine learning AI. I kind of mentioned the Monte Carlo simulations that Citadel runs with Nomad. But anything that's highly bursty, and we want to capitalize on the fact that cloud only charges me for the minutes that I'm running. So companies like Roblox, or maybe you've seen the Cloudflare case study that we had recently, where we want to right size the infrastructure dynamically and using a scheduler to make that happen on our behalf. So one last thing, and I'll wrap. But as we start looking to adopt cloud and DevOps, so we're seeing this demand of hey, go out and adopt all these latest and greatest practices. So you need all new skills, new processes, new systems, and by the way, don't break anything that's currently running. And well, that's kind of a big challenge. It's like changing the tires on a Ferrari that's doing 100 on the Autobahn. And so you end up with a lot of this where, hey, we really don't have time to modernize that because we're too busy lifting the current set of rocks that we have on our backlog. And so one of the things that we're suggesting is that we start with, we call it a sequoia and sapling sort of model, but the idea is carve a team out to practice and do something new to deliver more of a self-service environment. Naturally, we do not want to jeopardize revenue streams. We're not looking to become so intrusive and high risk with any changes that we make. So we want to segment it off where we can experiment and learn and grow. Anytime you're learning a new skill, you're going to make mistakes. We're going to configure things inappropriately. So we want to make sure that we build in the right processes from the get-go to mitigate those risks and ensure success. We also want to pick something that's valuable because we want to express what this automation can mean for the business holistically, and that leads to more, more funding. More success obviously breeds funding, breeds acceleration, and so it allows us to continue to grow the DevOps organization and kind of fold more and more of those best practice processes into the core trunk of IT. And so a lot of times we see a maturation curve that just kind of goes like this, where we're starting with infrastructure as code. As we get into infrastructure as code, we will find out that we've got exposed secrets. They just falls out. We'll see them in the logs and APM. We'll see it in our config code. And so we'll go ahead and start securing those secrets and removing them from clear text. And then as we begin to move more into production, we start seeing that, hey, now that we're super fast in infrastructure and I'm not exposing secrets and we're pretty secure, now it's not, I don't want to wait 3 days for a DNS assignment. And so we end up progressing into more connectivity, et cetera. And then finally, we're able to kind of get those fleets stood up. When we talk about use cases like Roblox that we mentioned earlier, that Terraform will lay down kind of the fleet of infrastructure that's going to be available. And it will go ahead and drop in like the Vault and Console and Nomad agents, so that as I deploy my new code out into my fleet of infrastructure, my connectivity is dynamic and automatic. My security is handled for me via ID and policy-based, and I sort of inherit everything as a service, and it allows me to move really, really quickly. And so I can have 100 million users in a month and still be developing games really, really quickly without a risk of like jeopardizing cash flow. One of the ways that we've seen a company do this is Goldman Sachs. They rolled Marcus out of the core trunk of IT and had them experiment. And they're a big, as a fintech, so looking to compete against the fintech startups and learn those methods that are worthwhile to fold back into the Goldman Sachs main trunk of IT. And then we've got Capital One who's working with us as well. Another expression that you may have seen in the marketplace for that Sequoia and the sapling is bimodal IT. Gartner will refer to it as bimodal IT. And that's just the idea that I have the more traditional legacy mode of operations, and I have another faster moving, newer, edgier operations model. Those are two separate things, and I'm learning and growing in both areas. But the hope is that the good ideas win, the things that produce the most value for the company continue to win, and generally we're seeing mode 2 grow rapidly. Success patterns, we need a sponsor. We need a clear line to value, and we want to do some hiring. We want to mix the teams where we have some new thinkers and we have some existing thinkers. And we want to blend those together because we're bringing the best practices from the past and the best practices from the future, and we're merging it into kind of a culture to drive the next gen of IT. And I will stop there and allow some time for question and answer.
Awesome. Thanks, Michael. Yeah, we have a few questions here, so I'll go through them. First, aside from infrastructure, security, and identity, what other types of self-services have you observed other operations teams deliver?
What other types of self-service have you observed other operations teams deliver? So infrastructure, security, identity are kind of those core, think of those as like electricity that you're going to be providing. And the services that are going to be coming out of like infrastructure are plethora. So the idea is that when I'm provisioning infrastructure, it could be something like database as a service. It could be things like and a new analytics service. It could be a backup and restore service. There's all kinds of services that get rolled out as a service, but it's still some form of infrastructure, security, identity, networking, connectivity. So the core, what we focus on at HashiCorp are kind of those core utilities that allow you to deliver all kinds of services to your end users, not just the core infrastructure, security, and identity. It just happens to be that that's where the HashiCorp plays. So you see Mongo, I want to deliver Mongo at scale. That's going to be a service that gets delivered by IT, but it's going to be done with best practice infrastructure, networking, and security.
Okay, gotcha. How have you seen silos prevented from domain experts like developer, networking, operations, security to instead suggest, collaborate, and make their respective services more API consumable?
So that's really a culture question. Besides being a tooling question. So hopefully this doesn't get too philosophical, but I've been discussing this with some friends of mine. And anybody heard of like Conway's Law? I wish we had kind of some open mics, but in Conway's Law, the idea is that when we produce software, we're extending our culture. Like we are replicating our culture in code. Specifically, Conway's Law says the way your teams communicate is how your code will be presented. So in essence, you're exporting, in a sense, your culture in software terms. So when you purchase software, you are consuming someone else's culture. And so I guess what I would look at there is, what is the cultural outcome that you want? If you want a collaborative environment, you may have to change incentives and tooling in order to make it more, call it more, if you're trying to introduce more of that collaborative world, you're going to have to introduce new process and or incentive. One way that I've seen prove successful, and this is going to go back to that sequoia and sapling. If you remove people from their existing environment, it's probably best to move them from their existing requirement. I use this as I'm not saying people are fish, so please understand, but I love to keep saltwater aquariums, and I'm into all this husbandry stuff. And if you're going to, animals in general are territorial. If I'm going to introduce a new fish, we'll say, and fish can be very expensive and beautiful, and I want to keep them alive. One of the ways that you break down territorial boundaries is by rearranging the aquarium. So I move things around, and then I introduce the new tenant. And this allows me to begin to break down that siloed approach. But yes, we see silos cause hangups all the time, mainly because those silos have defined their value to the organization a certain way. And you're going to have to shake that a little bit to redefine the value that team can present. I hope that answered the question.
Yeah, definitely makes sense. And I have a few more. I
Yep.
hear the term service mesh, console connect, and console connect service mesh quite a lot. Can you tell me what they are and how they play into console?
Sure. So so Console Connect is the idea that, so all of these service mesh concepts come into a general pattern of software where I am going to run a sidecar process with the service that I'm deploying. So the service gets deployed and next to it is like an Envoy sidecar, or maybe it's HA proxy or whatever. But the point is that sidecar is where that application only talks to the sidecar. So it's making local host calls. And that local host call goes to a sidecar, which checks with an agent that's running on that physical host or virtual host. And that agent will have like a cached set of instructions, policies, intent, all of that kind of stuff. And it also has connectivity information to any service that is going to be called by any service running on that local machine. So what I mean by that is I can dynamically connect without having connect information or going out to an external service. I have it all local with me. And so that Console Connect is just a way to say that I'm dynamically connecting to other services without having to go through kind of that ticketed process. I'm actually not looking for load balancers or firewalls between here and there either. It's just me connecting directly with another service with policy enforcement, mutual TLS, and whatever other policies I want to throw against that connectivity.
Okay. And then I have two Terraform questions that might be related, so I'll just read them both. One, what's the best way to check for policy while deploying a Terraform module with numerous resources and ensure proper hardening? Second question, you mentioned Terraform plan and then some policy before applying the configuration changes. Could you please state again how you achieve this policy step?
Sure. Yeah. So we created. So I'll answer it with a story. So we're working quite a bit with Barclays on automating their infrastructure. And naturally, as a regulated bank, it's important for us to maintain control and an audit trail on how infrastructure is being provisioned, when and how. And so we had used Terraform to shorten deployment times by, I don't know, huge percentage, like months to minutes to deploy infrastructure into production. But then we turn around and we're back up to weeks again. Weeks. Yeah, weeks down to minutes and then back to weeks again, maybe half as long as it used to be. And what we found out is we were having to manually audit the infrastructure before it got deployed. So what we were doing is we were taking that plan output, we were trying to make it human readable, and then we would hand it to an auditor who would compare it to like a Word doc of policies and see if anything had been violated before either allowing or denying the role of the infrastructure. And so they became kind of a design partner with us on a product that we call Sentinel. And Sentinel is a policy as code framework that allows you to codify the process, and it simply applies to the, between the plan and the apply phase of the Terraform execution. So yeah, it's basically just, instead of having a Word doc, if I can build a Word doc, I can codify that Word doc, and then I can have it dynamically compare, acceptable policies against that plain output.
Awesome. Last question, and then we can wrap up. Have you seen more mature Mode 2 companies such as Citibank also rethink their traditional audit process?
So that's kind of it's kind of a broad question in that that can apply to a lot of different things that we're talking about. So if I'm talking about introducing things like Vault, yes, we do change the audit process. The audit still needs to meet kind of SOX compliance demands, or PCI if I'm in retail or whatever. But the idea is that I'm actually simplifying. One of the reasons why we feel that we're getting such good traction with especially like financial or highly regulated industries is that we simplify the audit plan. So like if you are doing an audit process against, let's say, 4 public clouds and then 4 private clouds or private data centers that are all segmented with their own identity management solutions, their own identity records and policies and so on and so forth, that's a very, very difficult process to go through. And so what we are trying to do as HashiCorp is simply simplify that audit plane to make it easier to meet things like SOX and PCI compliance checkboxes. So if I can get all identity housed behind like a product like Vault, and then I can audit and tell you who accessed what, when, and how. When did they request that secret? Did they grant the secret? Did it violate a policy? Do we feel that there was a breach? And just understand breaches are going to happen, but can I root cause that breach like instantly? How quickly can I root cause and kill that breach, as an example? And so by simplifying the audit plane, by having a consistent approach at the network tier, at the security and credentialing and encryption tier, and then finally at infrastructure, then our goal is basically simplifying those audits. Making auditors happy is a big goal behind all of these products.
Great. Thank you so much for your expertise. We are going to be sharing the recording with everyone that registered. Someone did ask if the slides are available to share.
Yes, they are. I'll get them over, and feel free to distribute.
Okay, awesome. Well, thank you everyone for joining, and we hope you learned a little bit more about unlocking the cloud operating model. That does it for us. Have a great day.
Thanks, everyone.